Hi guys, welcome back to my channel. So on this video I'll be teaching you how to solve Doppler effect questions without racking your brain too much about the formula to use. So let me walk you through some of the things you need to know when solving Doppler effect. So the general formula for Doppler effect is frequency observed equals to frequency of the source into brackets v plus or minus u, velocity of the observer over v plus or minus velocity of the source. So now this is where the problem always comes from. Some people don't know when to use plus or minus. Some people don't know when to use plus, some people don't know when to use minus. So that's the main reason why I'm doing this video, for you to easily know what to use and what not to use. So now, first of all, whenever I want to solve a Doppler effect question, always draw the observer at the left hand side and draw the source at the right hand side. Just draw it this way, like this observer at the left hand side and the source at the right hand side. It's like you are drawing on the x-axis. This is the positive x-axis and this is the negative x-axis. So think about it like that. So now, whenever the question says when observer is approaching the source, then it goes this way, right? So it means the observer is going to the positive x-axis. That means that u of observer will be positive. That means that u will be positive. That means we are going to use positive sign from the formula. We're going to use positive sign from the formula. So now, whenever they said the source moves away, is moving away from the source. So whenever they said the source moves away from the observer, is also positive. Is also positive. You understand? Is also positive. So now, whenever they said the source moves towards the observer, that means it's going this way, right? That's us will be negative, so it means you're using negative here because it's us, so you're using negative as a sign. So use positive as a sign. Sorry, use negative as a sign. Whenever the source moves towards the observer, use negative because it's going to the negative x-axis. And whenever they say the observer moves away from the source, this is the source, so it moves away from the source, that's also negative. So UO will be negative, so it means you are using negative here. So now let's look at the question now for you to get what I'm saying. In this question, they said an observer hears a whistle from a stationary source with frequency. An observer hears a whistle from a stationary source with frequency 528 Hz. What will be the apparent frequency when it moves towards the whistle of a speed 20 meters per second? Also, what will be the apparent frequency after it passes the whistle? Take velocity of sound to be 330 meters per second. So now, first of all, you write the formula. That's F equals to Fs. F equals to Fs equals into brackets V plus or minus UO over V plus or minus US. So now you draw. This is the observer and this is the source. Let's write the parameters we have. We have the frequency of the source, which to be 528 Hz. We have the velocity of the observer to be You have the velocity observer to be 20 meters per second, and you have v to be the velocity of the sound, that's 330 meters per second. So now be 330 meters per second. So now you draw like I taught you the other time. Like I said, an observer hears a whistle from a stationary source. The source is stationary with frequency. What will be the apparent frequency when he moves towards the when he moves towards the whistle? That's like this. So that means that UO is positive because it's moving towards the positive x-axis at a speed of 20 meters per second. And also, what will be the, so let's solve that one first because they asked us to solve two things here, so we'll solve this one first. So it has to be FO equals to frequency of sound from the formula, that's 528 into brackets, V is what, 330, that's 330 because it's going to the positive x-axis, that should be plus, that's 20 over 330 plus 0. You don't need to write 0 because the source is stationary, it's not moving, so it has to be 0. You can leave it, you cannot, so you know what to do there. So now input this inside a calculator and see what you get. That's 330 plus 20, that's 350, right? So 528 times 350 divided by 330, that's 560. So you get 560 as when it's moving towards the source. Now ask us also, what will be the apparent frequency when it passes the whistle? That is, when it's receding, after passing the source, what will be the frequency? Now this is tricky. They said after passing, that doesn't mean that it will go this way and then pass. No, it means that, after passing is also receding, like it's going, it's not coming towards the source, like it's going out of the source. So it has to be like this. Don't draw to this side, or maybe like drawing like something like that. It has to be because it's receding, like it's going out of the source. It has to be, so it will not be like it's going to the negative side, so that UO will be negative. So it will not be FO equals to 528 330 minus 20. Remember, because it's going to the negative side of the x-axis, over 330. So input this inside a calculator, you get 330 minus, that's 310, right? So it's 528 times 310 divided by 330. So you get 496 as your answer for the question. So as simple as that. Just remember, the observer is on the left and the source is on the right, and then you are good to go. You don't need to remember every condition from the question, from the formula. You don't need to remember every condition, just know this and then you are good to go. Thank you for watching. Don't forget to subscribe and turn on the notification button to get notified anytime I post a new video.